Hello, everyone. So this is going to be section, well, I'm going to continue section 5.2, like I said in the last lecture, and also I'll be covering 5.3. Okay, so begin really quickly. We have assigned homework of 5.4 and 5.5, which I've been announcing a lot of times. That is going to be due this coming Saturday, which is October 24. And also 5.2 and 5.3 is going to be due on Wednesday. The reason for that is the exam 2 is next Thursday, which is October 29, and I'm covering till section 5.3 for that exam. So that's why 5.2 and 5.3 will be due on October. On Wednesday, October 28. Okay, so um, okay, now let's start, or let's continue this one. Uh, here, if you guys haven't watched my last video, please watch that one first. Okay, so last one, 5.1, and also 5.2, which I talked a little bit of 5.2 in the last video. So please watch that one, because I will be talking a lot of things I'll be referring a lot of things from that lecture, and I might skip a few things. So if you don't watch that video, it will be confusing in this one. All right. Anyway, so here we are trying to find the volume of the solid obtained by these two. Okay, so now, okay, at least we can find y-intercept. Okay, y is equals to x, means if I say x is 0, y is 0. Right. Similarly, if I say x is 0, y is 0, so it has to be at this point. And y is equals to x is basically, it's something like this line. And also, if you see y is equals to x squared, so as I said that in the last lecture, when you deal with a quadratic function like this, where if or basically if the coefficient of x squared is positive, rather than 0, then the graph is something like this, and coefficient is negative or less than 0, then it's something like this, right? So now at least we know that the graph would look something like this. We already said that it's going to go through 0, right? So something like this. Now we are trying to find the volume obtained by these two. So basically we're trying to find the volume of this reason. Okay, now we don't know this point, okay, but we know that we can find this 2 point assuming, okay, let's say this one, since these two are two different graphs, so I can assume this as f of x is equals to x, and this one I can say g of x is equals to x squared, right? Okay, now I can get that at this point saying f of x is equals to g of x. So f of x is x, g of x is x squared. Subtract x on both sides, so 0 is equals to, this one goes to other side, x. Now from these two, you can factor out x, so x minus 1. So now I can say either x is equals to 0 or x is equals to positive 1, right? Now, since we're trying to find the volume, and also I mentioned this, and when you're trying to find the volume that is rotating about y-axis, then I have talked about this in the last lecture. Then it will be pi times the interval, let's say a to b, of f of x and square of this and dx. It's similar to, well, we know that when you find the area of a circle or something like that, it's pi r squared, right? And when you're finding the volume of something, a cylinder or something, then it's basically pi r squared h, right? So here, this pi is this, r squared is basically f of x. So f of x is technically, we can assume this as the radius as well. And height, h, is d of x. Okay, anyway, so using this formula, now we can find the volume here. So that means x here, or this point here, is 1. Okay, so interval would be 0 to 1, since we're trying to find the volume that is rotating about x-axis. Okay, now so the volume will be pi, right? the interval we said it's from 0 to 1, and f of x, well here, okay, so the f of x, since we have two equations, since we have two equations, um, f of x and g of x, so here, and then there is a square here, so we need to take the square of each of these and subtract that. So what I'm trying to say here is, f of x square d of x minus g of x square d of x. Okay. And then after this, well, since these two has same interval, right? So basically I can combine this to a single and single integration. But f of x is x, right? F of x is x, and g of x is x square. So f of x is x, and if I take the square of that, it will be x square dx. And g of x is x to the power, or x square, and x to the power, another square is x to the power 4, right? And since, well, since these two have same interval, so that's why I combine this to a single integral. Okay, now it's all about taking the integration. Okay, so from here you will get x to the power 3, so x to the power 2 plus 1 is 3, over 2 plus 1 is 3, minus x to the power 4 plus 1 is 5, over 5, and the interval is from 0 to 1. Now plug this in here, so it will be 1 to the power 3 is 1 over 3, minus 1 over 5, minus, right? And after that, plug this this 0 here. 0 will make all of this 0, so that won't make a difference. So now when you combine this, it will be 2 pi over 15. So the volume is 2 pi over 15. Okay. Okay, now this one is, we have similar equations, or same equations. F of x is x, g of x is x squared. Now it's rotating about y is equals to 2. All right. So this one was rotating about x-axis. Now it's rotating about y is equals to 2. Now, so, okay, we know that the graph is the same, right? So this is f of x graph. This is g of x graph. Now, y is equals to 2 is basically a horizontal line that goes through 2. So this is 2. This is horizontal line. Now, since we're saying the volume of a solid that is basically a solid obtained by these two that is rotating about y-axis. Okay, so what here we are saying is basically we are saying the center of the volume of something is 2, because we are saying it's rotating about or it's rotating through this region or this line. Okay, so that means technically, well, here now we got to, like I said on the last example, it's similar thing. So here its volume is going to be pi, some interval. So basically when you, okay, so let's see, if you're finding the volume of just this region, of this middle region, okay, we are finding a similar case, right? We're finding the volume of this middle region. So if you're finding the volume of this middle region, and if this is the center, then the volume would be the first we'll be taking the volume of this whole bigger circle, right? And then the volume of this small circle, right? So in this case, we will be saying the volume would be pi of, or let's say this is a cylinder, something like that. So pi r, well, the r of the bigger circle, we say the radius or outer radius. square times h, some height, minus pi inner radius, let's just write I in an inner radius square times it's r. I'm just saying r means radius. Okay, so that's the idea, right? So it's similar concept here. So so in this case, since we're saying the center is 2, okay, so from this center, well, from here, the outer radius will be this g of x equation, and the inner radius will be f of x, right? So from 2, if this is the center, then here this g of x will be outer radius, like I said here, and this f of x will be the inner radius. Okay, so so what I can say here is so so the inner radius or the outer radius will be, okay, so this one is 2, so we are just finding this radius, so this radius will be 2 minus x squared, right? So the outer radius here will be, in our case, the outer radius will be 2 minus x squared, right? Because d of x is what outer radius, and take the square of that, right? Because we are taking the square, and dx minus the inner radius. Well, since we know the, oops, since we know, wait a second, since we know the interval, right? We already found the interval in the last example, so 0 to 1. So similarly 0 to 1, so the inner radius is now this line, x line, right? So that will be 2 minus x, and take the square of that. Okay, I hope you guys understand this one. Okay, I've tried to make it simple, explaining the similar example from here. And again, if you guys still have any confusion, please come to my office hour, because I don't see a lot of people in the office hour. I've been saying that, even I think I've said this in the email, the exam will be getting more difficult. All right, the first exam, I think it was very easy. The second was a little bit hard. Third exam will be even more difficult compared to exam 2. All right, so please understand the concept. Okay, now okay, so from this one, it's all about taking the integration. Okay, so now what we can do here is, since we have a square here, so I can expand this, right? So we know that well, we know that, let me just, here is this part. We know that a minus b whole square is a square minus 2ab plus b square. A plus b square is a square plus 2ab plus b square. This is a formula. I think you guys learned this formula in college algebra as well, or in the algebra class you took. All right, so so if I expand this using, well, this is minus, so there will be a square, or 4 minus 2ab is 4x square plus x to the power 4. Okay. Since well, these two has similar or the same interval, so let me just write it in the single interval, and there is a minus. Okay, now for this one, it's 4 minus 4x plus x square. Okay, so what do we do after this? Okay, so now for this pi, now we can basically distribute this, so that will give us 4x squared plus x to the power 4. This will be minus, this will be plus, and again this will be minus x squared and dx, right? So it's basically lots of algebra thing. Okay, so now I might skip a few things here. Okay, so this is gone, this is gone. So basically, if you combine all of these like terms, you'll be getting x to the power 4 minus 5x squared plus 4x. Okay, so now I think now you guys can integrate this, right? Let me just skip that. Okay, so you guys can do it. This is not a quiz problem. Okay, do this missing part. Do it yourself. Do the integration part. It will be a practice for you. So the final answer you'll be getting is 8 pi over 15. Yeah. Okay, so yeah, again, this is not the quiz. Okay, so it's only for you to practice. When I say practice, please do practice. Okay, don't think, okay, yeah, since he said practice, oh, we don't have to do anything because he's not going to grade it. Don't think that. It's for you. It's going to be a practice for you for the exam. Okay, that's why I've been skipping a few things. And also, I don't want to make this video too long, just explaining the algebra that you guys already know. Okay, so anyway, oops. Oh, okay, there you go. There's number 3 here. Okay, now again, find the volume of the solid obtained by, okay, same thing. Okay, now here we have now x, it's going to rotate about x is equals to -1. Okay, so again, it's a similar idea, outer radius and inner radius. So it's rotating about this, right? So from this reason, from this line, the outer, do that. Let me do this different color. So the outer radius is from here. The outer radius is x squared. The inner radius is x, right? So so that means, well, you don't have to worry about this negative sign. All we are looking is the distance. The radius is a distance. So this distance is, well, now from 0 to here, okay? So what I'm saying is, so from 0 to this graph, we are saying this is x squared, right? And from 0 to this line, we are saying this x, right? But now since, okay, you have to be careful here. Since now we are rotating this about x is equals to -1. So if you go to the last example, we were rotating this a horizontal line, right? This was a horizontal line. Now we are rotating this in a vertical line, right? So what we're going to do here when you're rotating this in the vertical line is, now you have to convert this like we did on the last the video. So f of x, we can say this is also y is equals to x All right, so basically we have to change this to x is equals to something, but since we already have x is equals to y, we wouldn't have to do anything with this one. But what you can do with this one is g of x, we can also say this is y is equals to x squared, or basically x squared is equals to y, right? Now if I take the square root on both sides, I'll be getting x is equals to square root of y. You don't have to worry about plus minus in this case, okay? Uh, so since now we are looking uh, on a vertical line that is rotating through a vertical line, now what we're going to do with the volume is, the volume, it's again similar idea, but it's just that now everything is going to be in terms of y, okay? So it's from 0 to 1. So if you look through y-axis, this point is also going to be 1. So that's why 0 to 1, okay, 0 to 1. And now the outer radius is going to be this one. It's not going to be minus, okay? This is, we're just going to take, well, this is 1, right? From here to here, the distance is 1. And we are also taking this extra distance. So that's why we are going to have a plus. So the outer radius we have here is this one, right? So because we changed the g of x to this in terms of y, right? So that's what we have, square root of y, okay? And then we are taking the square of this, okay? That's the outer radius, minus the inner radius is again 1 plus, now this is, well, since you are changing this to in terms of y, so x is equals to y, so y, and then take the square of that, dx, okay? Now, well, sorry, this has to be dy, so no, it's not dx, because everything is in terms of y, so that's what dy. Okay, now, again, it's basically algebra for this, okay? So if you expand this 1 plus, or a plus b squared, which I said in the last slide, it's this equation, or this formula. So if I use that formula, here if you expand this, this will be 1 plus 2 square root of y plus square root of y squared, which will be just y, minus, and we need to have this parenthesis because we'll be distributing this minus to all of these terms here. So 1 plus 2y plus y squared, and we need to take the integration in terms of y, right? So okay, so after you combine all of this, I will just now directly write what we'll be getting, distribute this, combine like terms. So be getting 2 square root of y minus y squared dy, and then take the integration. So on the exam, you cannot skip that I've been doing right now. The reason I've been skipping is I don't want to make this video too long, and since I have done these kind of examples a lot, so at this point, I expect that you guys know how to integrate. I'm focusing more on the concept on this part. Okay, the integration part, I assume that you guys know it. And if you like I've been saying, if you are confusion, or if you have, if there are any kind of confusion, or if you guys are not clear on anything, like I've been saying, please come to my office hour. That's why I have office hour. All right, so the final answer you get here is pi over 2. Okay, all right, now I have 2 more examples. Okay, now that, well, I'll be doing 2 other examples from 5.3. Okay, so the 5.3 is now the volumes by cylindrical cells. So on the cylindrical cells, what you need to know is basically we are looking at a cylinder, some kind of cylinder. Okay, so the cylinder, well, obviously we know that cylinder would be something like this. Okay, now when you're finding the volume of this, well, it's the circumference, uh, let's not make this like a specific example. Let's just look at this as a general example. Okay, so let's just look how the volume we're gonna say for the cylindrical cell. Okay, so the volume is basically let's just focus on the formula. Okay, so the volume is circumference, and the height and the thickness. All right, so basically we're multiplying all of this. Okay, the circumference of a circle is basically, we can say this is 2 pi r, right? And the height is, I can say, h. And the thickness is basically the change. So if you're looking the volume of a cylinder, basically there are some thickness, right? So basically the thickness is basically this one. Okay, so that thickness, we can say the change in r. Okay, the change in r. So bigger r minus smaller r. So that is defined by this. Now, how do you write this in a mathematical formula? So the mathematical formula would be something that we have been doing similar to that. So again, some interval, okay, 2 pi r, we will be assuming r as x, okay, x, and the height, we will be saying the height is a function, some function. Now we'll be taking the integration of this, and this delta r is basically change in r. I'm going to say d of x, the mathematical term. Okay, so now based on this formula, now let's find the volume of cylindrical cell of the solid obtained by rotating about y-axis region, bounded by y-axis. Let's just say y-axis bounded by f of x is this, and y is equals to 0. So as we know that y is equals to 0 is also same as x-axis, right? Okay, now now we're finding the volume of this. So now the graph of this would look well. Now the biggest or the highest power here is x to the power 3. Well, you can find the graph of this basically by making xy table. Okay, so give some value of x, get the value of y. So you can see how the graph is going to behave. Okay, so the graph would look, the shape of the graph would look something like this. Okay, now now what we need to focus here is we need to focus on this. What is the x-intercept? So we can find the x-intercept assuming y0 or f of x0, right? So from this one, because we don't have any interval, right? No interval is given. So we need interval later on to find the integration. So assuming this 0 is equals to 2x squared minus x to the power 3. So from these two, I can factor out x squared. So 2 minus x. So that means x squared is 0, or 2 minus x is equals to 0. So from here, x is 0. And from here, x is positive 2. So x is 0 is this, and x is 2 is this. I don't know how the graph is going to look like. I just assume that maybe it's something like this. And we have, like assuming this, we have 1 or 2 x-intercept points. So at least we know that the graph is going to intercept at these 2 points on x-axis. So that this part, I mean, it could be something different, but that's not really important. Okay. The main thing, the important thing here is x-intercept and maybe y-intercept, but we don't have any y-intercept here, right? Just because if you assume x0, y is also 0. So that's why the x-intercept and y-intercept point is this. Now, the main thing, okay, now after this, we need to find the volume, right? So the volume we can find, we know that the volume is 2 pi um, 0 to, well, it's 2, right? Because we found 2, it's from 0 to 2 of x and f of x dx, right? Yeah, 2 pi. I can bring this 2 pi out. So x f of x dx, right? X f of x dx. Okay, now 2 pi to x, and f of x is, we said f of x is this, right? So 2x to the power 3 minus x to the power 4 dx. And then from here, again, it's algebra. So 2x to the power 4 minus x to the power 5 dx. Okay, so now it's again a simple uh, integration after this. So 2x to the power 5 over 5 minus, oops, sorry, it's, what is it? Oh, 2x squared minus x to the power 3. So this is 2x squared to x. So if you distribute this, it will be 2x to the power 3, 2x to the power 4. Sorry. Now after this, it's 2. It will be, if you take integration, or if you integrate this, it's x to the power 4 over 4, x to the power 5 over 5 from 0 to 2, right? Okay, now again, plug this in here to these two, and minus plug this in here. So after that, your final answer is 16 pi over 5. Again, this middle part you have to do it by yourself. Okay, that's for you to practice. It's not the quiz. Okay. All right, so one more, last one. The reason I am doing all of these problems are probably you guys noticed that these problems are look similar, but there are little difference. Okay, so that's why I've been doing all of these different problems. So here it's rotating about y-axis. Now here it's rotating about x is equals to 2. Okay, it's rotating about x equals to 2. So that's why it's a little different. So the approach would be different. Okay. Okay. Anyway, so here again, y is equals to x squared. So this is a quadratic function where the coefficient is a negative number. So that means the graph would look something like this, right? And we know the x-intercept and y-intercept point would be the same, just because that if you assume x 0, these two will be 0. So y is 0. That's why we know this point. So the graph would look something like this. Now, what is this point? Another point, are basically the x are at x-intercept, y is 0, right? So whatever I did in the last example, so assume y 0, 0 is equals to x minus x squared. Factor out x, it will be 1 minus x. So from here, you can say either x 0 or x is equals to positive 1. So that means this one is a positive 1. Okay. Now, it's now rotating about x is equals to 2. So that is now another vertical line. So this is similar to what I did all the way back here. Right. So now here x is equals to -1, which was on the left hand side. Now it's x is equals to 2, which is on the right hand side from this graph. But anyway, so again, it's basically, it's now, well, we know that the volume here, let's try to find things through the formula. Okay, so in this case, what happens here is, well, since we said that this is the radius, right? I said this is the radius. This is height, 2 pi r, right? When I explained the formula, I said 2 pi r. So basically, r is the radius. So here it's basically, so since now we have only one graph, so the radius here would be this and this. Well, basically this is the radius. So this radius I can find is basically from here to here. Since we said this is 2, right? That's 2. And this one is x, right? So that means this is 2 minus x, right? So this one is 2 minus x, right? This whole thing is 2. And when you subtract this x, we'll get this one, 2 minus x. Okay, so that's why we have the new radius, which is 2 minus x. All right, so understand the graph. Okay, so try to find this making the graph. Okay, so when you draw a graph in the exam, I might ask you to draw the graph in the exam. So when you draw the graph in the exam, it has to be clear, okay? At least I should be able to read or understand your graph, okay? Now, the interval we have here is, since we said this is 1, right? So 0 to 1, 2 pi x. Well, make sure that you don't plug, you don't do that, okay? Don't do this mistake. Don't plug this x here. This x is different, okay? Or I might just say x1 here, okay? Just to make it different, just to make it look different. But anyway, let's not say that. Anyway, so x, we have new radius, which is 2 minus x, f of x, or this is also, we can say this is also f of x. So the f of x is x minus x squared and dx. Okay, so now after this, 2 pi is there. Now combine these two. Okay, so now you'll be getting from those two to x minus 3x squared plus x to the power 3 dx. Okay, so basically you can just take this out. So the volume is 2 pi, and just take the integration of 2x minus 3x squared plus x to the power 3 dx. Okay, so yeah, that's all, you know. So here the answer is pi over 2, but the thing is, make sure that when you find the volume of cylindrical cell, especially when I specify that cylindrical cell, then this is the formula, right? This is the concept you need to use. And if I say just find the volume, just the volume, then it's similar to 5.2. Okay, so from 5.2 I think I did 5 examples, right? The previous video I did 2, and on this one I did 3, so 5 different examples. And from 5.3 I did 2 examples. Okay, so make sure you understand the difference. Okay, So like I said, the cylindrical cell, it's similar to this concept. Just the volume is similar to 5.2. And if I just say area, then it's 5.1. Okay. Anyway, I'll see you on the next video. Please do the web assign homework on time. All right. Thank you.